Question number 27. A ripple tank and a barrier and a single gap are used to demonstrate the diffraction of the surface ripples on the water. Initially, the wavelength of the ripples is 5 times smaller than the gap in the barrier. Okay? The wavelength of the ripples, lambda, is 5 times smaller than the gap in the barrier. So, if this is dO here, I can write lambda equal to d by 5. Okay, which change increases the amount of diffraction observed. So when will the diffraction be clearly observed? The diffraction will be clearly observed when lambda is nearly equal to d. So what's happening over here? Lambda is equal to d by 5. Lambda is less than d over here. Okay, so you might get a diffraction but not up to that mark, but you want to see it in a proper way. So now let us, what is that I need to do? I need to see to it that this condition should be achieved. Lambda is nearly equal to d, which means what? I should now make this barrier graph smaller like this, so that this distance is equal to this distance, right? That's what I should do. Now let us read this. Double the amplitude of the ripples. No, this is not the right answer. Double the width of the gap. Already the gap is this much larger. If I double the width, then what will happen? The gap will look like this over here. Okay, this will be the gap. But I don't need this. I need this as my gap. This should be my gap, right? So therefore, this is also not the right answer. Half the frequency of the ripples, half the wavelength of the ripples. Now, closes, yeah. So half the frequency, half the wavelength. Now, when I say half the wavelength, what is happening over here? Already this is my lambda, which is nothing but d by 5. When I say half the wavelength, which means these waves will become smaller and smaller like this. Are you reducing this gap? No. Okay, compared to this, then this will become much more smaller. So definitely, the wavelength is also not the right answer. Only option left is C. So C can be given as the right answer. Okay.